All right. Thanks for coming tonight. And Martin Goebel of Goebel & Company Furniture is going to start us off with a presentation on his wood sourcing, his process, and his design ideas, and everything related to that. So
good evening, everybody. As Hayden said, my name is Martin Goebel, and I'm one of the co-owners of Goebel & Company Furniture, and we create wood residential furniture in a digital manufacturing environment. So the process that we're going to talk about tonight is mainly based on the concept through the creation of the cruise stool that we were just looking at over in the shop. For those of you who didn't make it over to the shop tonight, the cruise stool is just a small utility stool that we wanted to create so that it could be applicable to a lot of different uses, applications, you name it. We wanted to have that utility piece that would be the type of thing where if you're having drinks one night and you had 7 people over but only 6 people could sit on your living room furniture, this would be the thing that all 7 would want to sit in instead of the couch. So whether we achieved that or not, I'm not exactly sure, but originally we liked the idea of tractor seats. And I was actually working for a company in Maine, and I spent about 6 months driving across rural Maine and seeing these old rusted out tractor seats in just about every one of the 20-acre plots up there. So what we liked about it is it really defined the space. It was a very specific idea of, okay, this is how it's done. With a tractor seat, it was always very comfortable. It was the type of thing that you would sit in for a long time. But we wanted to take that concept and then bring it into the wood realm. That being said, the only chairs that are widely known that have that carved out seat, or that we really were interested in sort of mimicking, were Windsor chairs. Whereas the majority of Windsor chairs don't have nearly the rise and fall of the tractor seats. So the difference between the tractor seat rise and fall, especially with the one on the right, is probably almost 2 inches, whereas the Windsor chair is more of a stylized sort of cupping of the seat, and it's all done with a hand process. That being said, just the slight deviation from a totally flat plane allows the user experience and the sitting experience to be completely different than just a flat wood seat. And the easing of that is a really, really labor-intensive process. So it was one of those stool seats, or seats in general, that was going to be something that is a very expensive item very often, but in our digital realm, it would be just as labor-intensive as any other creation process. And because we're outsourcing everything, because of our use of 3D design and technology, we're able to create these seats at a production price point as well. So we originally started looking at commercially available tractor seats. On the right, you're seeing a tractor seat where people are literally repurposing existing tractor seats, whereas in the 1950s and pretty much previous to that, this was the tractor seat style. So there are a lot of them floating around out there. Then you go up to the stool that's in the middle, and it's a plastic formed seat, a little bit less contouring, obviously a different base. And then on the far left, you have the tractor seat, which is a fully CNC created seat, but it's still mimicking the general shape, contour, everything of that tractor seat. So we wanted to take that concept and then digitize it and see how we could play with it a little bit. So there was a significant portion of drafting, just got the general idea of what we were looking to do with our stools, kind of threw on whatever base we could generally think of that would be a little bit different than something on the right over there. And from there we went into our SolidWorks files, and what you see right here is the general creation method in SolidWorks. I'm not exactly sure how it works in Revit, but SolidWorks is a 3D modeling program that's based off of profiles that are extruded or lofted or revolved in order to create geometry in 3D. So we're mainly working off of profiles, the profile number 1 here, which is on the x-axis, and then profile number 2, which is on the y-axis. And that's to create the internal contours of our seat. And then we're using just a basic loft with a guide curve here that is creating our half of the seat. That being said, you can see a little bit of other geometry here where it's an actual larger seat, and I'll show you how that incorporates into our final production model, whereas this drawing reflects not only initial concept sketches and digital prototypes, but also the final production model, whereas in the digital realm we're able to take our initial prototype and look at it critically, where we like the look, we like the feel, but it was just too large. So we just reduced the size of the seat by about 7%, so you had a more intimate experience as opposed to having that extra 7% where it truly is only maybe about a ½ an inch on either side of the stool seat, but that ½ an inch changes things very dramatically with furniture. So this is, as I said, our basic model in the computer of our stool seat. Some of you saw our rapid prototype on the other side. We use that mainly to create to understand the composition of what we have in the computer as a whole, but the actual creation process is really based on a lot of prototyping. So in order to get that feel of it and to be able to cut quickly, we use a lot of pink foam and prototyping foam, where we're able to run a prototype seat in pink foam in about 20 minutes as opposed to about an hour and 3-minute creation process on the material-specific cherry or walnut. So what you're seeing here is a 3-axis CNC router. This is the tooling path computer here, where if it was a little closer up, you would see sort of a grid work on the top of the seat. And it cuts the top of the seat first, and then the seat is flipped onto a fixture which locates it correctly, and the underside of the seat is created. At this point, we take the completed seat, you sit in it, you put it at different heights, you adjust whatever you can, and then go back to your digital realm. From there, we take actual materials. These are cherry blocks. In this case, we're able to use lower grade timber simply because all of this is going to be milled away. The block that we have here is about an 18-pound block, and the finished stool seat, which we're working on here, you can see the general size and how it falls into that, is about 4 pounds. So by reducing that amount of material, you're able to use slightly lower grade material because you're going to be reducing that. So here we actually have the CNC milling process, whereas we weren't able to export the file, but it was actually a video for you to see. But with a 3-axis machine, the bit is always perpendicular to the table, so it will do an initial set of roughing out passes, and you can see how it's sort of tiered in the back here, and then the bit right here is our ball end mill bit, which is doing just little cleanup passes, and that's giving your end surface. So by reducing this block by that amount, we're releasing a lot of tension in the blocks. And when we get the stool seats back, we assemble them as quickly as possible to make sure that we don't have wood warping and things like that. So the first iteration of the stool that you see here is in the cherry seat with, I believe it's Indonesian black palm legs. The difference between this and the production seat, the main differences are the through tenons here with the wedges, which is very, very reminiscent of the Windsor chairs at that point. Whereas it's a traditional mechanically sound joint aside from the glue, whereas the leg is pushed all the way through the underside of the stool seat. and then a wedge is pounded into the top of the leg to spread the top of the leg. So essentially you're creating a wider top portion of the leg than you are the shaft of the tenon. So even if the glue fails in this situation, you still have mechanically sound joints. In this case, with our prototype, this was not put in with a CNC machine. We were using a 3-axis machine. In order for the CNC to put in the location and joinery, this bit would have to be able to articulate. The only difference between a 3-axis machine is, which is X, Y, and Z, are the axes of rotation, which are A and B, and in which case the 3-axis machine still goes up, down, left, right, side to side, but then the bit also articulates in whatever angle that you're looking for it to articulate in. So if this bit was able to come out at an angle like this, it could put in a joint right here at that angle specific to our joinery. So in this case, we're just drilling it by hand because it's the initial iteration. So from here, we're taking this initial prototype and we're re-editing our digital design. Whereas the difference between doing sort of basic hand design, as I'm sure all of you have experienced with any of your digital design software, is you can use it like a Microsoft Word as opposed to a typewriter, where instead of rewriting everything, we're just going back into our design tree and editing individual portions of it. So one of the portions that we really didn't like is that we had a very considered top surface, but then the underside surface wasn't being manipulated in any sort of way. It was just a big flat section down here. So iteration 1 and iteration 2 here are different mainly in that the underside is significantly more considered. We're doing returns on the underside of the legs, whereas up here it's truly that Windsor style where it's just pushed together and then there's a slight chamfer here on our edges. The underside here is also contoured, so the underside follows the contour of the top, so you're getting a much more I don't even know exactly what you would call it. You just have a much prettier transition between top and bottom surface. So we go from this being our initial prototype in the computer to this being our edited prototype, and you can see all the individual surfaces here that after CNC milling are offering this section here. One of the problems we're having with this that you don't see very readily in your digital models, and this happens quite a bit, is this little spine right here, which is directly relating to our initial digital models of not having this underside, the two halves, where this half initially is drawn as a single half and then it's mirrored. The joining of the two halves isn't done, or wasn't done originally, so it was tangent to each other. So we're creating this little section right in here. So there's a lot of that through your entire process needs to be really diligently looked at, because if you don't, by the time you get from here to here to here, there's probably about a $10,000 process that's occurred between engineering, tooling paths, continued prototyping. So in order to do a lot of this, what we probably should have done is cut a second prototype into pink foam or a rapid prototype, but it's little issues like that that are massive setbacks. So from there, we're going on to our cruise iteration number 2, where that's eventually ground out. But like I was showing you in our prototype iterations over in the shop, there are certain things in those prototypes where we were looking at a little bead around the top edge here that could be eliminated in the CNC, whereas this had to be all eliminated by hand. Where in the initial prototyping stage, it's not a problem, but by the time you get to populations of 10, 20, 30, to eliminate little underside curvature like that, that is purely just digital errors that the designer has put in there, it's better to go and just edit your files and go back and reevaluate. So finally, we have the Cruise 3 iteration, which is our production. If you look at the difference here, there's a little bit of different thickness in the front edge of the stool seat between number 2 and number 3. And number 2 and number 3 are all based on the difference of this one being created completely by hand and this one being created for production. Whereas the production, by leaving this thicker, is allowing more durability in the stool, more strength directly in the joinery here. Just a little bit of tweaking. So going from number 1 to number 2, you have a significant amount of change, and number 2 to number 3 you have minimal change, and then so on and so forth through those iterations. But the nice part about our current process is that you're able to edit those little things throughout that will create a better product, a better producible product, an easier producible product. So the iterative process is really just invaluable. So that is the end of the presentation I've created for you. All of our products are done in this same manner, some more, some less. Mainly the products with more organic curves spend more time in the creation process and in the prototyping process, because a straight, square, flat tabletop generally doesn't have a lot of changes that can be made to that. So when it comes to Revit as opposed to SolidWorks, there are a number of different creation abilities, but with regard to CNC, the files you're generally exporting are DXF files and DWG files, and then they're able to create 2D and 3D tooling paths off of those. But each one is a little bit different, so depending on the CNC machine you're using, they're going to dictate the type of file. In order to get Revit files to transfer to SolidWorks files, you need to export to what's called a .step file, which is just something in your drop-down menu. And from there, the STEP file can be opened in SolidWorks. And it's not necessarily a SolidWorks or a Revit file. It's that sort of mutually understood file. And then the 3D can be created in SolidWorks off of the 2D from the Revit, or vice versa. So, if there are any questions, I can answer those, but otherwise, thank you so much for your time and stopping by the shop, and if there's anything I can ever do for you, please do contact me.
And how much waste do you have?
I'm sorry?
How much waste? 50% waste?
On the stools, it's significantly more than 50% waste. We're taking, like I said, about an 18-pound block in cherry and reducing it to a 4-pound block. So there's a significant amount of waste in the actual tractor-style seat. Well, in this case, it's a solid piece, but with production, we're creating that with 3 pieces, where if you can see here, there's one here, and one here, and that's mainly for wood movement. When you mill a significant portion of wood out, you release a lot of tension. You know, if a tree was leaning to the right or it was grown on a hill, there's going to be one side in tension, one in compression. So now you have cut the tension and compression out, and you have a board, and that board is dried, and then it kind of stabilizes. But now we're doing the same thing as milling the tree down by doing this to it. So by adding 3 different boards with opposing grain pattern, we're restricting the movement of the other boards within the stool seat, whereas in this type of a stool, there's nothing restricting that seat movement. So this is more aesthetically pleasing, but it's not as reproducible.
Is this a process that's done with other types of furniture? Is this something you...
It is a process that is definitely done with a lot of production furniture. Most of the Chinese-made furniture these days is not using it simply because it's more expensive for them to use CNC technology than it is to have just human labor do it. But it's a process that you're seeing more in smaller scale American and European furniture manufacturing, simply because it reduces human labor and it's very, very accurate, and it allows you to do a lot of shapes that are not repeatable otherwise. Yes,
How
sir.
much finishing do you have to do after this milling?
We're getting about a 90 to 95% resolution on all our components when they're being created. In this case, or sorry, in the case of the initial prototype here, we're doing a significant amount less creation in the CNC because all we're trying to do is get the tooling path. So if you look at the front edge here, it's pretty crude, but if you saw the front edges of our production stools and the prototypes we had over there, there's a lot more surfacing that goes on because in this case we're just trying to prove the concept, whereas over there we're trying to reduce the amount of labor. In this stool, post CNC creation processes with the lathe turnings and the milling, we're at about 45 minutes per stool from raw components to finished product. But that's probably spread over about a week and a half, mainly due to glue drying, various finishing times, things like that. But about 45 minutes if that solves.
For an average stool, from the beginning to end, once it's set up, you have it where you like. How much time does it take to make a stool here?
With the actual CNC processes and all of that?
Yeah, when it's finalized, and you
Yes.
approve it, how long, like in production sense, does it take? Like 74 hours?
Well, it's difficult to say exactly because it's all based on batch production. If you had to set up your CNC router, we always run a test just to make sure that we're not going to destroy about $100 piece of, or actually it's about $54 for a seat blank. But that's all based on volume as well. If you bought that one seat blank retail, just went to your local woodworking store and bought the wood, you'd probably be around the $150 range. But because we're doing 30, 40, 50 blanks at a time, we're ending up at about $54, and then we're speeding up the entire process. And it's really hard to narrow it down to just the one time, but our actual shop labor for one stool is about 45 minutes. And that's from the time that the parts come into the shop to the time we're done sanding them, assembling, finishing, waxing, and ready for purchase. That being said, it's about an hour and 4 minute CNC creation time for the seat. And the seat is cut in two halves, whereas the top of the seat is cut first, and then the concave section is flipped over onto a tool or a fixture, and then the underside is milled afterwards, because the concave section going down on a negative of it will restrict the rotation and movement of it. So
you theoretically take this metric file and do it in
yes. Most with metal milling operations, it's a little bit of a different process, and you probably wouldn't use the same individual creation of it because the joints between metal and wood are significantly different. There's no reason to use as large a joint in metal. Most likely you would have things spun on a lathe and just butted together and then welded together and then ground down, whereas here we're using actual tenons, mortise and tenon joinery, things like that. But if you wanted to mimic this exact style in metal, you could create all of the components in steel, aluminum, whatever you want. But you know, you take a chair or a stool right now, it's weighing about 7 pounds and exponentially increasing that. The cleanup of these shapes to mill it out, say you did it in steel or aluminum, it's a different sanding and finishing process, where the stool would probably be more applicable to casting of the stool seat as opposed to milling of it out of billet. So, depending on your material, the creation process drastically changes, and then you need to design specifically for the easiest method of creation for that material. And it changes very, very specifically with wood and metal. Whereas on this initial stool here, you look at this rod here, and it's probably three-quarters of an inch or an inch in diameter, where you could do the same thing, have the exact same strength on this stool with probably quarter-inch rod and steel. But they're using that, I assume, as an aesthetic sort of right proportion kind of deal. But what a quarter-inch rod of steel can do is probably far superior to what a 2-inch thick piece of wood could do. So. Thank you so much.
Thanks, Martin. See if the recording